In this lecture, we're going to cover section 3.3, valid argument forms part 3. So this section is going to build on the previous two sections, and there's going to be two more commonly used argument forms that now involve conjunctions. The first one is the conjunctive addition, typically abbreviated CA. And symbolically, it's expressed as the argument has two premises, so P and Q, and then the conclusion is P and Q. So basically, if we're assuming our premises are true, right? If P is true and Q is true, then the conjunction P and Q, right, is also going to be true. So let's construct a formal proof for the following two valid arguments. So the first one we have here is an argument with three premises and a conclusion, right? I'm already telling you it's valid, so we don't have to test for validity. So what I want to do is let's construct a formal proof. So just like we were doing in the previous lectures, we're going to set up our little table, right? So we have statement and then the reason, right, for our statement that we're saying is true. And a lot of times it makes sense to start with a premise that's a simple statement, right? Because oftentimes that's used in the other premises. So for example, P, right, my premise, I'm going to start with that one because I see I also have premise 3 right underneath it is R implies not P. So I see a conditional statement, the right-hand side is negated, and then I have that single simple statement P, right, which is the negation of not P. So I'm thinking this looks like modus tollens. So for statement 3, I'm going to say that not R is true because of modus tollens, right? So we're using that on statements 1 and 2. And don't forget that statement 2 is true because it's a premise. So next, really, I have one more premise, right? The first one, not RNP, implies S, but I don't really have anything yet, right, in my previous statements that if I use that along with one of my previous statements that I could use, one of the argument forms. But I do see that the left-hand side of this conditional statement, not R and P, right, that contains an R. And it looks like it was joined with P, and P I already have as my first statement, right? And we're assuming it's true because it's a premise. So I'm thinking, okay, I could use my conjunctive addition, right? I could join those two simple statements. So for statement 4, we're going to have not R and P. So that's true based on that conjunctive addition. And that's going to be on statements 1 and 3. So now I'm thinking, okay, now that I have not R and P, right, which is the left-hand side of the conditional statement, let's write down the conditional statement, right, our last premise. So not R and P implies S, right? So that's a premise. And now look, let me take a different color so it's easier to see. So you see how the left-hand side of my conditional statement in 5, right, is also the statement in number 4, which looks like the pattern for modus ponens. And I'm going to be left with S, right, as a result of modus ponens, right? So that's going to be on 4 and 5, statements 4 and 5. And we're working our way closer and closer, right, to this conclusion. So we want to show that the conclusion is true. And it's a disjunction, right? So I'm thinking, okay, I could probably use one of the formal argument forms in the previous lecture. And since S is true, right? We just showed that, then I can say S or B is also true, right? Because no matter what I join with a true statement, the result is still going to be true. So that's my disjunctive addition. So disjunctive addition on statement 6, right? I joined S with B through the disjunction, and that's going to be true. And that's our conclusion. So that wraps up that formal proof. So let's look at the next one. This one's also a valid argument. So let's set up our statements and reasons. So I'm going to start with that first premise. It's a simple statement, right? Not S. Premise, right? And then I see right below it, I have not S implies Q, right? And not S in the first statement is the left-hand side of that conditional. So I'm thinking modus ponens, right? So modus ponens on statements 1 and 2, right? So that's gonna leave me with the statement Q, and I'm sorry, I got one step ahead of myself. So not S implies Q is a premise. And then the way we stated Q is true is because of modus ponens, right? On 1 and 2. So now I have one premise left, right? Which is P or Q implies R, but I don't have much to do with it right now, right? Because I'm thinking, all right, it's a conditional. Maybe if I had the negation of the right-hand side, that would be modus tollens, but we don't have a not R. But I do have part of the left-hand side, right? P or Q, we have Q. We know Q is true, so I'm thinking we could use the disjunctive addition, right, to make this statement P or Q, right? I could join it with P and it's still going to be true. So this is the disjunctive addition, and I applied that to statement 3. And now I have the left-hand side, right, of my premise that's left. So let's state that premise. So we have P or Q implies R, right? So the reason is it's a premise. That's why it's true. And then again, let's use red. You see how we see the pattern for modus ponens, right? I have the left-hand side, P or Q, of this conditional statement right above. So then we can say that R is true, right? Modus ponens on 4 and 5. But my conclusion is Q and R. But look above it, statement 3. We know Q is true. We showed it, right? And statement 6 is that R is true. So now I could use my conjunctive addition, right? So I can say that Q and R is true based on the conjunctive addition. So that's going to be for statements 3 and 6. And that's our conclusion. And that wraps up that formal proof for this argument. So the other argument form that's in this section is the conjunctive simplification. So it still involves a conjunction, but look, it starts with the conjunction P and Q, and then we could say, okay, therefore either P is true or Q is true, right? Because the only way that P and Q could be true, a conjunction is true, is if the left and the right-hand side are both true. So if I have P and Q and I know it's true, therefore P has to be true. Or if I know P and Q is true, that means both P and Q are true, therefore Q is true. So let's see how we could apply this. So let's look at the next valid argument. So let's construct another formal proof for these two valid arguments. So let's make our table. So we have statement and reason. So I only have two premises. One of them is a conjunction. So I know if I had to, right, I could conclude that either P is true or Q is true. And I see in my second premise, I have a conditional statement and the right-hand side is not P. So what I'm thinking is, all right, let's state P and Q, right, because it's a premise. But let's use the conjunctive simplification to conclude P, right? Because if P and Q are true, then P is also true, right? By the conjunctive simplification from statement one. Now, let's write down the second premise, not R implies not P, right? That's a premise. But you see how the right-hand side of the conditional is not P, and I could put that together with P, right? So that's modus tollens. And then my conclusion would be the negation of the left-hand side. So we would get R. So modus tollens on statements 2 and 3. And that's helpful because R is in my conclusion, right? But my conclusion is R and Q. Now, I don't have a Q anywhere here, right? So that I could join them because I'm thinking, okay, what if I use my conjunctive addition, right? But I need Q somewhere. But based on our statement one, we can also say that Q is true, right? Based on the conjunctive simplification. So now I'm ready to say in statement 6, R and Q is true by the conjunctive addition. And that's for statements 4 and 6. So the key to these, because, you know, we have a handful of these argument forms so far, right? Think whenever you see conjunction, think either, okay, it could be the conjunctive addition or conjunctive simplification. When I see conditional statements with a simple statement, I'm thinking, okay, maybe modus tollens or modus ponens, and then you have your two disjunctive argument forms too, right? So that's kind of how you have to think about these. It really depends on what the connective is in each one of these premises. But obviously, the more you do with this, the more practice, right? The more you're going to see it and the easier it's going to become. So let's look at one more and then that'll wrap up this section. So we have kind of a big argument here, right? We want to show formally that it's valid. So let's list our statements and our reasons. So just scan and kind of look at your premises and see like what stands out to me is you see how I have a P or a Q, which is the left-hand side of the conditional, right, in the first premise. So I'm going to start with those. So I'm going to start with P or Q implies R, right? That's a premise. And then we also have P or Q, and that's true because it's a premise, right? So we're done with the first and the third. And since I have a conditional statement first, right? And then the second statement is just the left-hand side of the conditional, that's modus ponens, right? So that's going to leave me with R. So we just applied modus ponens on statements 1 and 2. Now I see that I have an R in the fourth premise, right? But it's R or S. But the fact that I know R is true, right? I can say that R or S is also true, right? Because of my disjunctive addition. I can add a disjunction, in other words, to a simple statement or a variable that's already true. So that was on 3, the disjunctive addition we applied to statement 3. And then now I'm going to write down that fourth premise in statement 5 because that's the left-hand side, right? R or S implies W. The left-hand side is what I have in statement 4, right? So again, I see the pattern for modus ponens. And that's going to leave me with W. And don't forget, statement 5 is a premise. And then to get 6, we did modus ponens on 4 and 5. So we're making progress. We have W now, and I see in my second premise, we have W and R as the left-hand side of that conditional. And I have an R in statement 3. So the fact that R is true and W is true, then we could say that R and W or W and R is true, right? By my conjunctive addition. So that's going to be on statements 3 and 6. And then now that's the left-hand side, right? Statement 7 is the left-hand side of premise 2. So I'm going to write down premise 2. So W and R implies M. It's true, right? Because it's a premise. So we have one more premise to show is true before we get to the conclusion, right? And I see 7 and 8, right? Like we said, I see that pattern for modus ponens again, right? Because 7, that statement in 7, W and R is the left-hand side of the conditional in 8. So then I'm going to have M. So modus ponens on 7 and 8. And I see my last premise, which I'm going to state in 10, right? Not M or B contains a not M. So now we have to say that B is true, right? So let's think about this. I'm thinking I have a disjunction, right? I have not M or B. And we want to state that B is true. But look at my previous statement. It's M. So this reminds me of the disjunctive syllogism, right? So remember, for the disjunctive syllogism, if we have P or Q and not P, right, that's going to leave us with Q. Or if I have P or Q and not Q, that's going to leave us with P, right? So you see how we have not M or B and not M, right, which is M. So that's going to leave us with B. So the disjunctive syllogism on 9 and 10, right? Because we have this pattern right here. And now we're done, right? We just showed that B is true. So this wraps up section 3.3. We're going to continue in the next lecture with section 3.4, and then we're going to start adding equivalences, those equivalences that we learned previously, right? We're going to start adding those into our proofs.